So in this video, we are going to quantitatively analyze by what amount the mass m2 is going to come down. We are going to derive an expression for it using the terms and the different parameters given, right? The solution for the first part of the question you can find here. The link is given, and this is the second question of part A for the first question, right? The question is again saying that we release the two masses m1 m2 initially from this position. So by what amount m2 is going to come down and stop? Okay, so that delta y has to be found out. So I'll make the diagram once again. So this is the situation initially. We release the two masses from this situation here, right? And let's say after releasing, the situation is something like this. The spring gets elongated by some amount. Mass m1 comes here, and whatever is the elongation in the spring, by the same amount, the mass m2 comes down. So this is delta y as well if the elongation in the spring is delta y, because the length of the string here is not changing. So whatever is the elongation in the spring, by the same amount the mass m1 will be moving ahead, and by the same amount the mass m2 will be going down, right? Because the length of the string is not changing, right? So now I'll use the conservation of mechanical energy to analyze by what amount the mass m2 is going down, right? So the total mechanical energy initially, I, mechanical energy is the sum of kinetic and potential energies, right? And the total mechanical energy is conserved because there is no non-conservative forces acting in the system. What are non-conservative forces? The forces like friction, drag forces, viscosity. Work done by these forces are lost in the form of sound, heat, spark, and these things, right? So no such force is there in the system here, and there is no external force acting on the system also. So the total mechanical energy is going to be conserved. Fine. So initially, let's say this height here is h naught. Okay. Initially, m1 was from the ground surface was at height h1, and then later on it came down at a height h2 from the ground, right? So the initial mechanical energy, nothing was moving initially, the kinetic energy is 0. So the total mechanical energy for m1 I can write, this is m1 g h naught, right? Plus the spring is in its natural length, so no potential energy in the spring, right? For mass m2, the potential energy is m2 g h1, right? And finally, after the release, m2 comes to a momentary stop after coming down a distance delta y. Still nothing is moving, so kinetic energy is still 0, but now the spring is elongated by this amount delta y. So there is some potential energy in the spring now, right? So the total mechanical energy finally is going to be, for this m1 mass, the potential energy is the same. The height for m1 is not changing, okay? So it is still m1 g h naught. Potential energy of m2 is now m2 g h2. Now this is elongated, so some potential energy half k naught, the spring constant is k naught, it is given to be k naught here, into delta y square, right? So this much potential energy comes in and got stored in the spring. These two are going to be equal because the total mechanical energy is conserved, no external force, no non-conservative forces acting, right? So the total energy is in the system stored. So I equate these two, initial mechanical energy equal to final. So if I equate, you'll see that these two terms will cancel each other out. The remaining I am equating here, okay? So I'll be getting m2g h1 is equal to m2g h2 plus half k naught delta y square, right? So I'll bring this term this side. I will get m2g H1 minus H2 is half K naught delta Y square, right? From here I can say this H1 minus H2. H1 minus H2 is nothing but delta Y. So for this thing, I'll write delta Y. M2 G delta Y is equal to half K naught delta Y square. One delta Y cancels with this one. So you will be left with delta Y is equal to M2G upon K naught. So this is the expression. So 2m2g k naught. This is the expression that we have for delta y using the conservation of total mechanical energy for the system, right? So this becomes the answer. That is what the question is asking. Express your answer in terms of k naught, m1, m2. There is no m1 here, but yes, I have m2, g and k naught in my answer. So this here becomes my answer for this question. Okay, thank you.